Welcome to Spring LIB.
In this exercise, we have a hawk that's carrying a rat 200 meters above the ground with a speed of 10 meters per second to the right. And at a certain time, the rat breaks free from the hawk and starts freely falling. The hawk stays on its path for 2 seconds before diving in a straight line with a constant speed towards the rat, and the hawk catches the rat 3 meters above the ground. In question A, we want to find what is the hawk's speed when it's diving towards the rat. So first of all, what we need to calculate is the total distance that's traveled by the hawk, and in order to do that, we need to calculate how far horizontally the rat travels. And for that, before calculating how far horizontally the rat travels, we need to calculate how long does the rat freely fall. So I'm going to start with that. I'm going to start with calculating the time t it takes for the rat for the hawk to get the rat back. So first of all, notice that the trajectory of the rat is the trajectory of a projectile that's launched horizontally. This means that v0x is just the speed of the hawk. That's the initial speed of the rat. That's 10 meters per second. And v0y is 0. It starts with no vertical speed. Also, notice that I've set up a coordinate system up here in black, where the origin of the coordinate system is in the exact place where the hawk broke free from the, where the rat broke free from the hawk, and the y-axis is pointing upwards. So this means that y0 is 0, and so is x0 for the rat. And now we can use, and also it's important to notice that the final y, when the hawk gets the rat back, the final y of the rat is minus 197 meters. Okay, that's just 200 minus 3. And we're going to find what the final x is. So I'm going to use the equation for the y-coordinate. So y equals y0 plus v0y, t minus 1/2 of gt squared. y0 is 0, and so is v0y. So we get y equals minus 1/2 of gt squared. In our case, y is minus 197. This is equal to minus 1/2 times 9.8 meters per second squared times t squared. So t is equal to the square root of 2 times 197 meters divided by 9.8 meters per second squared. So t is equal to 6.34 seconds. That's the time that the rat spends freely falling. And now we can calculate the final x coordinate as x0 plus v0x times the time t. So xf is x0 is 0, of course. v0x is 10 meters per second times 6.34 seconds. So this is 63.4 seconds. So we can calculate now. So what we have is that the final y-coordinate of the rat is minus 197, and the final x-coordinate of the rat is 63.4 seconds. I'm sorry. Of course, here shouldn't be seconds. It should be meters. So 63.4 meters. And notice that I'm just gonna draw again the rat's and the hawk's trajectory. So this is the rat's trajectory. We have here, for the height, we have 197 meters, and for the horizontal distance, it's 63.4. The hawk's trajectory, on the other hand, is a straight line, and then it dives. And we are only interested in the diving. We know that the hawk travels for a time of 2 seconds before starting to dive. So this horizontal line here is a horizontal line of 2 seconds of flight for the hawk. Since the hawk has a speed of 10 meters per second, this here is equal to 20 meters. Okay, so this means that the straight line of the descent of the hawk has 197 meters in the y direction and only 43.4 meters in the x direction. And then we can calculate the total distance traveled by the hawk. And the total distance traveled by the hawk, r, is equal to 197 squared plus 43.4 squared. And this is equal to 201.7 meters. And we know how much time it took the hawk to go towards the rat, because we know how much time it took the rat to fall. So the rat falls in a time of 6.34 seconds. But the hawk only starts to dive towards the rat after 2 seconds. So the time it takes for the hawk, th, to dive towards the rat is 4.34 seconds. That's 6.34 minus 2. So the speed of the hawk, v, is r divided by the time that it took the hawk to travel a distance r. So this is 201.7 meters divided by 4.34 seconds. And this is equal to 46.5 meters per second. In question B, we have to find the angle with the horizontal that the hawk does when it's diving towards the rat. Again, notice that the y-coordinate here is 197. The x-coordinate is 43.4, of course, 43.4. And we want to calculate the angle with the horizontal. This means that we want to calculate this angle here. And notice that theta is the arc tangent of 197 divided by 43.4. And this is equal to 77.6 degrees. So this here is the answer to question B. And in question C, we have to calculate how much time the rat spends freely falling. And that we have already calculated in question A. That's just this t here. It's t equals 6.34 seconds. So from question A, t is equal to 6.34 seconds. And this concludes the exercise.